Hello again. Here is an example of an alternating series, and it's sort of the typical example in some sense. So we're looking at 1 over n, but with positive and negative signs alternating. So we start with n equal to 1, so that's minus 1 squared, which is 1 over 1. And then when n is equal to 2, we get minus 1 cubed, which is minus 1 over 2. So that's minus a half, then plus a third, minus a quarter, and so on. So let's look at what happens to the partial sums. The first partial sum includes just the first term, so that's 1. Now the next term that we add is negative, and so we're going down. In this case, we're going down to 1/2. The next term is positive, so we're moving back up, but we're moving up by a third, which is less than a half. And so we move down by a half and up by a third. We wind up at 5/6, which is less than the previous sum. So the sum of the first 3 terms is less than the first term, and both of these are bigger than the sum of the first 2 terms. Okay, now we're going to subtract a quarter, so that's going down. It's going down, but not by as much as we went up before. We went up by a third, we're going down by a quarter, and so the sum of the first 4 is lower than the sum of the first 3, but higher than the sum of the first 2. And the next term is going to be positive, so we're going to move up, but we're going to move up by not quite enough to get to the third partial sum. So the 5th partial sum will be bigger than the 4th, but less than the 3rd. The 6th partial sum will be less than the 5th, but bigger than the 4th. The 7th is going to be less than the 5th, but bigger than the 6th, and so on. We wind up moving around in here, and the question is, of course, what happens, but we certainly don't break out of this this interval between between a half and 1. And so it's plausible that the series eventually winds up on some accumulation point. That's in fact true. It's a property of the real numbers that this actually has to happen, that there has to be some accumulation point. And since the difference between the partial sums, the actual terms, are going to 0, that means we're actually having to approach a limit value. And so this is an example of an alternating series and an explanation of the reasons why, with the condition that the series always alternates and that the size of the terms is steadily decreasing, so we're moving closer and closer together, then the series has to converge.